Yeah, so I was requested to fill in for another presentation that didn't take place. And I will present some of our work in the field of gpgpu. When our, I mean some of the work of the TCE, of the Technion Center of Computer Engineering. I'm a PhD student, as Avi, I think, mentioned. So I'm a student of Avi, Mendelssohn, and Asaf Schuster. And I'll break our activities into 3 domains. So the first one is industrial affiliation, how we work with the industry. The second is our educational activities in the field of gpgpu. And the third is research in gpgpu. Okay, so Avi mentioned that we're participating in a consortium, in a national consortium that is called Metro 450. The purpose of which is to make better metrology tools. This tool, so this is a schema of metrology tool, and this tool is used for process control of wafer production. So in the production of wafers, of chips, these wafers are checked for errors so you can see in the machine that there's a wafer in the middle. There's a signal collection, which is photos, which is photo of the wafer and other measurement tools. The data is collected and computed in the nearby computing platform. And the computing platform is there nearby, not for, I mean, it's there for a reason. It's there because the data rates are very high in this processing, and it needs to be close enough to be processed on time, because this is actually a real-time system. If some damage is detected on the wafer, so the wafer should be put out and taken out of there in real time. Okay, so there's several things we're doing in the Metro project. We are concentrating on the compute side, so we're concentrating on processing the data efficiently and transferring the data efficiently into our systems. Even now, the demand for processing capability is very large. And as we move from 300 millimeter wafers in diameters to 450 millimeter wafers, this demand only grows, and we need to process more and more data. And this is a problem now. So we have limited time to increase our processing throughput by an order of magnitude. The way we're going to try to approach this problem is to examine domain-specific solutions for the algorithms used in this project. Okay, so this is one of the things we're working on. We have purchased a gpGPU system, a multi-GPU system. Actually, 2 servers that are connected with InfiniBand. One with 4K20, K20M, which is used for, this is a constant configuration. We're using it to run high, to test our CUDA code. These are NVIDIA GPUs that is used for processing images and running linear algebra algorithms. The other system, we have 4 slots to put other cards. We want to try the implementation of these algorithms on different architectures. whether it's NVIDIA, whether it's Intel or AMD. So we have these slots to switch the cards between them. And we're comparing different architectures, also within NVIDIA. All right. Our second domain is coursework and projects. The Technion was recently recognized as a CUDA Research Center by NVIDIA, who also contributed the K20M GPUs. So thank you for that to NVIDIA. With Avi, we did a course last semester for undergraduates and graduates, and 63 students participated, which is very nice. The students optimized the convolution kernel in CUDA and OpenCL, so they learned both CUDA and OpenCL, and they also learned about the GPU architecture. And each student, so except for the general assignment, the student did also private assignments in pairs. Each pair worked on a different topic. And okay, so I'll present some of the works, a few of the works. And so some of their works were also extended to semestral projects. Okay, so I'll run rather quickly over these examples of the students' work. So one of them was of image reconstruction. And the students implemented several algorithms in OpenCL, ran it on 4 GPUs, and achieved nice acceleration. One of the outcomes of this course was to see how beginner GPU programmers gain expertise and can accelerate their programs further and further. We saw that to write an efficient code, you need to both design your code to the hardware and do code optimizations, which is also very important. For example, we saw that after implementing an algorithm in CUDA and then writing it down in OpenCL exactly the same, by further using OpenCL specific optimizations, the students were able to increase the performance significantly in OpenCL over their previous CUDA implementations. So this was regarding the convolution kernel, which was very nice. So this work was done in OpenCL. Another work was done in PyCL. It was quite new to us. The students implemented several image, let's say, image alternation algorithms like cartoon style and oil rendering. And so you can see their conclusions in the end that writing in Python is easy enough, like, relatively easy, but not very efficient in runtime. So what does it say? Performance-oriented code shouldn't be written in Python. Okay. Another work is fast community detection algorithms. So this is a graph problem. Students implemented an algorithm that finds these clusters of closely connected nodes in the graph. This was implemented in CUDA, and by trying different approaches and several optimizations, both on, for example, sorting approach and other parts of the algorithms, they were able to achieve very nice acceleration. Okay. So this is the list of all the works, of all the topics of the works. I like this slide. All right. The last slide will be, so this is the last slide about the research. I personally am doing research on scheduling real-time data processing on systems with accelerators such as GPUs. We have several papers on on scheduling real-time data streams on heterogeneous systems. So the publications are listed below. Currently, we're also working on scheduling communication, which was a topic that was raised several times today. So we're also scheduling communication for real-time workloads. And also somewhat of GPU performance modeling. That's it for me. So, thank you.
Question. Okay, if there are any question, I'll try to wrap up in a few minutes. And so, 5:55.
You can take the mic.
Okay. So, first of all, thank you very much for everybody who came and participate and contribute, and of course to the Metro that actually support the event. We really hope to make at least twice a year event and to keep the community, because we believe that it is very important to create a kind of community that will work together on common problems. As we started about the TCE, we want to form some kind of collaboration between the Technion and the industry, and if possible, maybe even between academia and other academias, but this is much anyhow. And so this is one of the first steps toward this direction. You are always welcome to come and share your problem with us and work together for solutions. Few specific comments that I gathered during the day. One comment is about the gentleman there that said that after the previous talk, the one before that, he will not touch the GPU anymore. So my comment is, great, it's called job security. So we need to preserve our ability to have some kind of uniqueness. To be on more serious side, there were many comments about what Eli referred to about OpenCL and the agility of CPUs versus a GPU and so on. I think that there is something very, very basic here. The message of the CPU, when we establish the CPU, you are wasting too much power in order actually to recover from not sophisticated programmers who write program. So if you write your program correctly, we can produce, or according to our rules, we can produce a hardware that will work much more efficiently. Great. Now we are complaining. If we don't follow the rules, and if we write a not proper software, then you don't give me the functionality. So I'm not saying that the complaints are not justified, but it's just against the principle of developing the GPUs. So maybe we need to find another principle, because the current principles are quite simple, giving enough parallelism that doesn't have any dependency, and it will feed the hardware, and we will run it very efficiently. Maybe they are not realistic, and maybe we need to find some other basics or principles in order to build a better GPU system, or maybe go to the direction that Intel took, and instead of looking for better a graphic card just build a better parallel system that brings us to the heterogeneous era and not particular to the graphic area that we have a lot of implication from graphic to general purpose and so on. So if you have more questions, comments, it will be great. Do you want to ask something, to comment? If not, so thank you again for coming, and I hope to see you in future events. And